Yo, 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 what it do, man? This is your boy North End Floyd, man, back with a reaction review. You know what I'm saying? I appreciate y'all kickback family for chilling with your boy. You know what I'm saying? Supporting, sharing, and liking. So please subscribe. Please do all that good stuff for your boy. You know what I'm saying? And we'll continue going down this journey, learning this and discovering what's going on out there. You know what I'm saying? Whether it's space or you know what I'm saying in the water or wherever. You know what I'm saying? But man, we've been hearing a lot of things about Proxima B since James Webb telescope been out there, you know what I'm saying? We've been seeing all kind of shit, you know what I'm saying? We've been seeing it up close, we've been seeing shit far away, you know what I'm saying? We've been getting great details. But Proxima B, you know what I'm saying, it's sizzling out there, you know what I'm saying? It's a little hint out there in the you know what I'm saying, in the science world about, you know, is it life out there, bro? So we finna get to this reaction video, man. Y'all already know what we finna do and stuff. But you know what I'm saying? Like I said, like, share, subscribe, do all that good thing. You know what I'm saying? And let's kick back. Let's watch this reaction review and see what they're talking about.
Humans have long conjured up images of what life might be like on distant planets. When the
Facts.
search for exoplanets entered its golden era, interest in Earth 2.0, our planet's twin, circling within the habitable zone of its star, increased. However, searches have so far come up empty, forcing researchers to employ some creative thinking to locate another possible home for life in the universe. That query can now be resolved thanks to the James Webb Space Telescope. The most powerful telescope in the world will provide fresh resources to answer the age-old question of whether or not there is life outside of Earth. Join us as we explore James Webb's terrifying discovery of city lights that changes everything. The
Yeah.
only life we are aware of so far is on Earth. People have questioned if there is life in the universe since the dawn of civilization. The search for extraterrestrial intelligence SETI.
Wait, I don't know why we still trying to question if aliens is still out there, bro. You know what I'm saying? Like the universe is so fucking big out there, bro. And we're still like a young civilization, man. We only been on Earth for like, you know what I'm saying, just like a tiny little speck of what the universe has been out. You know what I'm saying? So I just think that's kind of like naive to think that, you know, it's nobody out there. You know what I'm saying? And also I'm not gonna prolong, but I think like, you know, type three, type four civilizations is out there watching us. We just can't detect it. You know what I'm saying? So let me get back to the story. My bad, kickback family.
Project was started in 1984 by American astronomers Jill Tarter and Thomas Pearson to conduct such interstellar searches.
Yeah.
The nonprofit organization's goal is to collect radio transmissions from space because radio waves are less scattered or absorbed than other types of radiation. They can travel farther and are therefore more likely to be picked up by the 42 radio telescopes that make up the unique Allen Telescope Array in the Californian Cascade
Okay. Okay.
Mountains. However, no confirmed alien signal has been picked up in 30 years. After that, research was helped by the successful deployment of the James Webb Space Telescope, JWST, the largest telescope in the world, which is floating about 1 million miles from Earth and equipped with extraordinary.
Yo, they said nothing has been detected in 30 years. Imagine working that job and you're just chilling, just trying to listen for some shit and nothing happened in 30 years. You're really just milking that job. You know what I'm saying? That's an easy ass job.
Extremely sensitive detectors will study a variety of distant, undiscovered planets orbiting far off stars. Other than the planets in our solar system, no other planets were recognized 20 years ago, but more than 4,000 more planets, sometimes known as exoplanets, have since been found orbiting other stars.
Oh, fuck that. That's a throw
According to
beat.
NASA, there could be trillions of exoplanets in the universe.
Trillions.
Extraterrestrial plant life may provide the earliest indications of life outside of our solar system.
He said
Last Galileo
trillions.
Galileo spacecraft turned its instruments back toward Earth and detected the definite sign of the presence of plants. The vegetation red edge VRE biosignature, a combination of red and infrared light reflected by plants, was picked up by the device. If there is an Earth-like planet covered in jungle, for example, it should have a strong VRE signal that should be simple to detect. The JWST
Okay.
will measure the VRE of distant Earth-like planets in the habitable zone around stars. The makeup of the exoplanet atmospheres may contain significant indicators of life. The JWST may be able to detect sunlight passing through an exoplanet's atmosphere when it crosses the face of its star. The missing wavelengths in the light would subsequently be found using spectroscopy. The atmosphere's atoms and molecules absorb particular wavelengths, leaving a distinct fingerprint that the JWST can detect. With this approach, the atmosphere's makeup may be discovered, and the potential for life can be deduced.
Okay.
If Earth-sized planets with atmospheres like our own were discovered, with a predominance of oxygen, nitrogen, and carbon dioxide, those planets would probably be able to sustain life. And it could be possible to spot technological life by checking for the presence of substances that don't happen to occur normally. Chlorofluorocarbons, CFCs, which are produced for use in cleaning products and refrigeration, would likely be visible to aliens observing Earth's atmosphere from a distance. CFCs in planetary atmospheres would be a telltale sign of a civilization if the JWST discovered them. In fact, life on exoplanets might not resemble life on Earth at all. Even earthly life, such as extremophile species, can occasionally appear.
What the hell is that?
This is a group of organisms, primarily bacteria, that can survive in conditions that would make it impossible for other living things to survive. Some of them can tolerate temperatures as high as 250 degrees Fahrenheit. Others can endure temperatures as low as -4 degrees Fahrenheit. Others exist on Earth in locations where we would not anticipate finding any life at all.
What the hell is that
including
shit, bro?
some that live in strong acids with pH levels below 3. However, it would be wise to start looking at Earth-like planets first, since they are more likely to host life than planets with extreme temperatures or acidic environments. Prime candidates may orbit a stable star and have temperatures that permit liquid water to exist on their surfaces. Our sun is characterized as a yellow G-type star, but in our universe, these stars are less frequent and typically have shorter lives. Planets revolving around red dwarf stars, which are more prevalent and have a lower luminosity and temperature than the sun, may be a more likely subject of study. Because of the substantially longer lifespans of these stars, there is more time for the emergence of life, for evolution to produce complex life forms. JWST's initial mission will examine the TRAPPIST-1 planetary system, around 40 light years from Earth. It comprises 7 rocky planets the size of Earth around a peaceful red dwarf star. In the so-called habitable zone, 3 of the rocky planets could have liquid water on their surfaces, despite having a considerably smaller and cooler mass than our sun.
Now, just because it's in the habitable zone doesn't mean that, these planets going to sustain life, because you got to understand Earth, Venus, and Mars is all in the habitable zone, and just Earth has water. You know what I'm saying? I don't, they say Mars used to millions of years ago, but it doesn't now. But I'm just saying that just because it's in that habitable zone, that Goldilocks zone or whatever, that doesn't mean that it has life. But, we can only assume.
The TRAPPIST-1 star, because of its planet's tight orbit, emits light that is comparable to that of Earth. Proxima Centauri, a red dwarf star that is 4.25 light-years away from the Sun and our closest star, offers us the best opportunity of observing city lights outside of the solar system. A planet must be 20 times closer to Proxima's furnace than the Earth is to the Sun in order for it to support life based on liquid water.
Come on, get to the good juicy part.
This star is approximately 600 times fainter than the Sun. In this habitable zone, astronomers identified a planet in August 2016 that weighed 1.3 Earth masses. The fact that Proxima b orbits its dim red dwarf star Proxima Centauri at a distance of only 4.6 million miles raises the possibility that it is a lifeless, airless planet. In contrast, Earth is 93 million kilometers from the Sun. Proxima b is in a tight orbit that provides enough sunlight for temperatures similar to those on Earth and liquid water, but it also exposes the planet to strong solar winds that can completely destroy its atmosphere. Proxima b is believed to be tidally locked, showing the same side to the star at all times as the Moon does in relation to Earth as a result of its close proximity to the star. There is a permanent day side and a permanent night side on Proxima b. Sadly, models indicate that tidally locked planets' atmospheres may be vulnerable to rapid collapse as volatile gases freeze out on the night side. However, volcanic activity can also replenish atmospheres, and on planets with powerful magnetic fields, these atmospheres are less likely to escape. We are unable to even speculate about Proxima b's likelihood of having an atmosphere because we have no knowledge of the planet's volcanic activity or magnetic field strength. But we're desperate to know, since an atmosphere implies the existence of seas, and the two combined imply the existence of life. If a sophisticated civilization already exists on Proxima b, its day side may be covered with solar cells to provide electricity that would light and warm the night side, which would otherwise be too cold and dark for comfortable habitation. The JWST enters the picture here. The infrared heat signature on Proxima b holds the key to detecting the atmosphere of the planet. Additionally, Hubble's successor has a strong affinity for the infrared region of the spectrum, so the James Webb Space Telescope might be able to see city lights on Proxima b's night side permanently. Webb could detect artificial
Damn, try to detect it, bro.
illumination as long as it was restricted to a frequency band that is 1,000 times narrower than the starlight, even if it were as weak as what our civilization currently uses on the night side of Earth. Based on its distinctive spectral edge in reflecting starlight, Proxima b's day side is covered in solar panels to a significant extent. There is no difference between day and night as Proxima b orbits its star. The temperature is hot during the day and cools at night. However, because an atmosphere and ocean transfer heat, the temperature difference between day and night depend on whether the planet is made up entirely of bare rock or not. In other words, if there is no atmosphere, the temperature differential between Proxima b's day side and its night side will be greater. In fact, we can compute the precise amount of blackbody radiation that should be there because the day side will re-emit all the energy it gets from Proxima Centauri as a black body. On the other hand, the night side will resemble a frozen version of hell. We can assume the existence of an atmosphere if there is a less dramatic temperature differential between day and night. Conveniently, the JWST will quickly complete its orbit around Proxima b, taking only 11.2 Earth days to measure the infrared radiation.
Oh, so we sending the James Webb out there?
The next stage will be to determine the composition of Proxima b's atmosphere, assuming that it does have one. In particular, we'll want to keep an eye out for substances like oxygen, water vapor, and methane, because they might point to the presence of habitable conditions, if not living organisms. However, to do this, we must capture starlight as it reflects off or passes through the planet's atmosphere, which is a very challenging task.
Yo, man, shout out to the James Webb, man, because we've been finding out a lot of shit. You know what I'm saying? Like, pictures that we've been getting before have been blurry and you can't tell, and it's like it wasn't even worth looking at. But now with the James Webb, man, it's like it's all clear. You know what I'm saying? It's more definite, defined, and stuff. So I'm kind of dope. You know what I'm saying? Stoked on this idea. Like if we send James Webb close to Proxima b, you know what I'm saying, to see what it detects. But let me also twist y'all brain. So it's a day side and a night side. Just imagine, you know what I'm saying, it's a civilization on the day side and a civilization on the nighttime, and they don't like each other or something like that. You know what I'm saying? It's like, it's crazy, bro. So my dog's in the back tripping.
However, because Webb was not designed to search for extraterrestrial life, the telescope can only closely analyze a few of the closest potentially habitable worlds. Additionally, it is restricted to monitoring changes in water vapor, methane, and carbon dioxide concentrations in the atmosphere. Even while some mixes of these gases may be suggestive of life, Webb is unable to detect the presence of unbonded oxygen, which is the strongest indicator of life. The extremely large telescope, which is anticipated to start operations in the middle of the 2020s, is one of the upcoming ground-based observatories that will be able to perform a full atmospheric analysis. The JWST may be able to detect a few compounds, including ozone. A cutting-edge concept for the future, even more potent space telescopes includes ideas to block the glaring brightness of a planet's host star in order to expose starlight reflected back from the planet. To better view something in the distance, think of doing something akin to blocking the sun with your hand. Small interior masks or big exterior umbrella-shaped spacecraft could be used in future space telescopes to accomplish this. Studying light reflecting on the planet is significantly simpler after the starlight is obstructed. Meet humans. Let us know what you think in the comments section below.
Like I said, man, the James Webb is just the only beginning. I'm hoping that we could send more dope ass telescopes and all that, you know what I'm saying, satellites to, outer space, so we can get a more clear answer to, planets out there, and see if they have, stars with, civilizations and stuff like that. But like I said, man, we're out there trying to find these planets and these solar systems that can habit, different species and aliens. We need to be prepared because everybody's not friendly. We're not even friendly. You know what I'm saying? So we're looking, but we also need to be prepared for the worst, just in case these motherfuckers be like, hey, we don't like y'all and all that, or y'all are inferior to us and we want y'all water, all kind of shit. But I appreciate y'all for kicking back, checking out that review. Excuse my dog, he was in the back. He's probably barking at some people out there in the window and stuff like that. So, just keep tapping in, Kickback family. Remember to like, subscribe, and share, And I'll see y'all again, man. Y'all be safe, y'all be blessed, and y'all be 100. All right, I'm out.